day everyone. I am Dr. VNSR Venkateswara, working as Associate Professor from Freshman Engineering Department in Institute of Aeronautical Engineering, Hyderabad, Telangana. So today I would like to give the topic on water softening methods. First of all, what is the meaning of softening? Softening means to remove the impurities, that means dissolved impurities from the sample of water. That is nothing but to remove the permanent hardness of water. So it is called as water softening methods. Water softening methods, water is mainly softened by the chemical treatment methods. It is divided by the internal treatment methods and external treatment methods. Internal treatment methods, conditioning of the water in the boiler itself by adding the chemicals, whereas external treatment methods, treatment is done before entry of water to the boiler. That means with respect to the boiler, we can classify either the internal treatment methods or external treatment methods. Internal treatment methods, first one is the Kalgan conditioning. It involves the adding of the sodium hexametaphosphate to boiler to prevent scale and sludgy formation. Kalgan converts to the scale forming impurities into highly soluble complexes. That means sodium hexametaphosphate dissociates to give the sodium plus sodium phosphate, and 2 moles of calcium sulphate reacts with the sodium phosphate to give the soluble complex ion calcium phosphate with the byproduct of the sodium sulphate. And next one is the phosphate conditioning. Phosphate conditioning mainly involves the sodium hydrogen phosphate scale can be removed by adding the appropriate sodium phosphate. That means sodium hydrogen phosphate or sodium phosphate. The phosphate reacts with the calcium and magnesium salts, forming loose sludge or calcium or magnesium phosphate, which can be removed by the blowdown process. That means 3 moles of the magnesium chloride reacts with the 2 moles of the sodium phosphate to give the magnesium phosphate with the byproduct of the 6 moles of the sodium chloride. The choice of phosphate salt depends upon the alkalinity of the boiler feed water. Calcium can be precipitated at a pH of the 9.5 or above. Trisodium phosphate is most suitable for the treatment when the alkalinity of the boiler water is low. By adding the sodium phosphate, scale formation of calcium sulphate can be prevented. By adding sodium phosphate, scale formation of calcium sulphate can be prevented. When we added sodium phosphate, the concentration ratio of the phosphate ions to sulphate ions is increased than the solubility product of the ratio of the calcium phosphate to calcium sulphate. That means phosphate ions or sulphate ions is greater than the calcium phosphate or calcium sulphate. Later, it will be saturated with respect to the calcium phosphate but not with respect to the calcium sulphate. Therefore, the solubility product for the calcium sulphate will not be reached, and hence no scale of the calcium sulphate will form. That means saturation means the solubility product of the water should be equal to the ionic product of the water. So it is the meaning of saturation. Next one is the colloidal conditioning. Colloidal conditioning mainly involves the colloids like tannin, agar-agar gel, kerosene are added to the boiler. They form a coating around the scale, forming particles and thus prevent them from aggregating together to form a scale. This method is effective in case of the low pressure boilers. Colloidal conditioning especially applicable to the low pressure boilers. External treatment methods. In this external treatment methods, it involves the ion exchange process, deionization or demineralization of the water. That means this process involves all the dissolved salts from the sample of water. Ion exchange process is defined as the reversible exchange of the ions in the structure of an ion exchanger to ions solution that is brought in contact with it. The resin used for the purpose are called ion exchange resins. They are porous, insoluble, cross-linked, long-chain organic polymers capable of exchanging ions. The 2 types of the resins mainly employed for the softening of water: cation exchange resin and anion exchange resin. Cation exchange resin mainly are the materials capable of exchanging a cation in their structure to the solution. Softening of the water, the resins used should be capable of exchanging of H plus ions in their structure to the cations in the solution. Commonly used resins are styrene divinyl benzene copolymers, which are sulfonation or carboxylation become capable of exchanging hydrogen ion with the cations in the water. They are represented as a RH bond. That means R is equal to insoluble polymer matrix and H is the exchangeable ions. That means the structure is the R single bond H plus. That means R is the insoluble polymer matrix and H is the exchangeable ion. And next one is the anion exchange resins. These are the materials capable of exchange of anion in their structure to anion to solution. Ion exchange is employed for the water softening or styrene divinyl benzene or amine formaldehyde copolymers which contain basic functional group such as amino or quaternary ammonium or quaternary phosphonium or tertiary sulfonium groups as an integral part of the resin matrix. They are represented as ROH. That means R is equal to insoluble polymer matrix and OH minus is the exchangeable ions. Amberlite 400 and Dovex 3 are the examples of commercially available anion exchanges in marketly. That means Amberlite 400 and Dovex 3 are the main examples for the anion exchange resins. Once we remember what are the cation exchangers and what are the anion exchangers. Cation exchangers are the Amberlite IR 120 and Dovex 50 are examples for the commercially available cation exchangers, and Amberlite 400 and Dovex 3 are examples for the commercially available anion exchangers. So this is the structures of the cation exchangers and anion exchangers with styrene divinyl benzene. Cation exchanger is mainly containing the sulfonic acid groups, that means represented by SO3H. Whereas anion exchangers are represented by the CH2 bondage link with NH amine bondage link. So these cation exchange resins are applicable to exchange the H plus ions from the water, whereas anion exchange resins are applicable to replace the OH minus ions from the resin. Finally, the H plus ions and OH minus by the combination to give a water molecules. And what is the process of the cation exchange and anion exchange? The hard water is first passed through a column containing the cation exchange resins. That means cations are removed and equivalent amount of H plus ions are released from the column of the water. So these are the equation. Chamber has low pH cation exchange resins are 2RH. This is the structure of the cation exchange resin. It absorbs the calcium ion molecules and resin absorbs the calcium and releasing of the H plus ions. If magnesium ions present in the water, if magnesium ions present in the water, that resin absorbs the magnesium ions and releasing of the H plus ions. Then the water is passed into a second column containing the anion exchange resins. That means all the anions are removed and an equivalent amount of the OH minus ions are released. That means ROH plus chlorine gives rise to the resin with the chloride, releasing of the byproduct of hydroxyl ions. 2 moles of ROH plus sulphate ions, R2SO4 plus 2OH minus. And if it is carbonate anions are present, that means that anion exchange resin ROH reacts to give the resin carbonate with releasing of the hydroxyl ions. The H plus ions released from the cation exchange resin column and OH minus ions released from the anion exchange column combine to produce the water molecule. The water coming out of the exchanger is free from the all the cations and anions. That means the ion free from the water is known as the deionized water or demineralized water. And after that, the finishing the procedure, it is required to regenerate the both cation exchange resin and anion exchange resin. After some time gap, the resin loses all their H plus and OH minus ions and then their to exchange the ions lost. For a condition, the resins are said to be exhausted. The cation resin is exhausted resin generated by passing a dilute solution of the hydrochloric acid. That means the resin filled with the calcium ions and giving the formula resin with calcium R2Ca and reacts with the hydrochloric acid and regenerated to give a fresh resin with hydroxide. That means calcium chloride. If it is magnesium filled with resin, that is also react with the hydrochloric acid to give a fresh resin with the formula RH. with magnesium chloride. The anion exchange region is also regenerated by passing a dilute solution of sodium hydroxide and then washing with the distilled water. That means resin with sulfate ions with sodium hydroxide to give a resin with hydroxide with the byproduct of sodium sulfate. If it is filled with the chloride salts, that means sodium hydroxide again reacts with the to give a ROH plus NaCl. The salts are removed by washing with the distilled water. This is the block diagram for the ion exchange process. While you observe the left side present in the cation exchange region and right side present in the anion exchange region. That means initially the sample of water introduced into a cation exchange region, that means hard water, it can be removed the salts of calcium and magnesium, various salts, by cation exchange region by the replacement of the H plus ions. Whereas the right side present in the anion exchange region, it can be replaced the salts like chlorides and sulfates by the usage of the OH minus ions regions. That means initially the sample of water introduced into a hard water inlet from left side into cation exchange chamber with the help of the gravel and cation exchange regions, it can be replaced by the calcium and magnesium salts. After that, it introduced into a anion exchange region and it can be removed by the salts like chlorides and sulfates, and it can be removed by anion exchange region. After that, to get a soft water at neutral pH, that should be equal to a 7. That means the sample of water, it should be free from all the dissolved salts, but the water coming out from the cation exchange region having water with low pH. But after the sample of water coming out from the anion exchange region should be always equal to the pH. That means the sample of water should be used for the any type of the process because of the neutral pH. And after that, finally the cation exchange region should be regenerated by the dilute acids like hydrochloric acid, and anion exchange region will be regenerated by the dilute base, nothing but sodium hydroxide. So this is the overall phenomena for the ion exchange process to remove all the dissolved salts present in the water. It is the best phenomena to remove the both temporary hardness and permanent hardness. So it is the best chemical treatment method for the any sample of water. And what are the advantages of this method? The process produces the water with very low residual hardness, that means about 2 ppm. It should be applicable and useful for the boiler process. The process can be used to soften the highly acidic and alkaline water. It should be removes both cations and anions. But whereas in the zeolite process, it can be removed only cations but not anions. So this is the best method of our zeolite process. But what are the disadvantages of this method? The process is expensive, both the equipment and resin are costly. Turbid water decreases the efficiency of the process. These are the disadvantages of this method. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.